there's a big group of people who are good at something, a big group of people who are bad at something. That might sound like that's a pretty spread out distribution of talent, but not really, because as long as there's a large number of good people and they're all about the same amount good, those are the only people who are going to end up in the industry. And so it's going to look like the talent is all clustered together. One thing I should note is all the stuff we're going to be talking about today comes out of thinking that, from the work of this guy, Xavier Gebex. And he is actually on campus today giving a talk, not about this stuff, about something totally different. But anyways, if you see a French guy walking around the halls of the department, that is the guy who did all this stuff. So the top part of the distribution of talent is called the tails of the talent distribution. And if there's lots of people who are very, very good, much better even than the next best people than them, then we call a distribution fat-tailed. This is the case when the geniuses are much better than even the next best people. And it means that there's a highly unequal distribution of talent. Another term that's usually used for this is called black swans, when there's sort of like these very, very extreme events that occur rarely but are very important. Often, it's assumed that there's thin-tailed distributions. And in fact, if you take most of the standard statistical distributions, like normal distribution, et cetera, that you would use, that's already assuming away the existence of these fat tails. So in fact, a lot of people criticized financial firms during the crisis for having used assumptions about normal distributions because they assumed away these extreme events. And it's not surprising that there would be these extreme events if in the economy there is an extremely fat-tailed distribution of talent, as we'll talk about in a moment. Because when there's a fat-tailed distribution of talent, then the biggest firms are going to be much bigger than the next biggest firm. And so a shock to those firms is going to cause much bigger effects on the economy than shocks to slightly smaller firms would. And so you would expect that if different firms get hit with shocks at different times, that there's going to be a fat-tailed distribution of outcomes in the economy. Okay. And all the data that we have indicates that the distribution of talent, firm size, things like this that have to do with prominence of social phenomenon is extremely fat-tailed. In fact, they usually follow what's called a power law or a Pareto distribution. And a Pareto distribution has a cumulative distribution function. This is what we were talking about earlier. That's the probability that you're below a certain level in the distribution of talent follows this law. It's 1 minus the talent that you're currently at divided by the minimum talent that anyone has in the population to the negative power of alpha, where alpha is some parameter. Some ways of thinking about a Pareto distribution is that the fraction of people with talent above 2x is 1 over 2 to the alpha times the fraction of people in the above the level x. Now, to get a sense for that, imagine that alpha is equal to 1, which is a case we'll focus on. That's saying that there are half as many people who are twice as talented as me as there are people who are at least as talented as me. That means that the talent is really not falling off much at all as you go up the talent distribution. That happens all the way up. So no matter how talented you are, there are still half as many people who are twice as talented as you as people who are as talented as you. If alpha is equal to 1.2, then 20% of people have 80% of the talent. Another way of putting this is that the fifth most talented person is 1 over 5 to the 1 over alpha as talented as the most talented person. Or the second most talented person, if alpha is equal to 1, is half as talented as the most talented person. So that's like huge gaps at the top of the distribution, right? And many distributions related to talent or heterogeneity of size or ability or visibility follow this pattern. So for income distributions, alpha is usually thought to be somewhere between 1.5 and 3. For wealth distributions, it's somewhere between 1 and 2. For CEO compensation, how well compensated are the CEOs. It's about 3. The most prominent one is when alpha is equal to 1. That means that the 5th person is 1/5 as big as the first person. And I'm going to show 2 examples of this graphically to you guys. But it also has been shown to hold for the comparative advantage of different countries in producing different goods and for words in the English language. So the most commonly used word is used twice as much as the second most commonly used word. The most commonly used word is 3 times as much as the third, etc. OK, so if we graph either, and this is part of your homework assignment, the logarithm of the rank of something like a firm or against the logarithm of its size, we should get a negative downward slope of 1 exactly if Zipf's laws holds exactly. This is some industry, I don't remember which industry it is, and this is the number of firms, this is the size of firms, and this is how frequent firms of that size are in the distribution of all firms in the whole economy, right? So this is their size in terms of employees on a logarithmic scale, and this is the frequency with which they occur. And that's another way of representing things where if you have Zipf's law, you should get exactly -1. And here's what you get. It's pretty astonishing. If you guys ever get in your senior thesis a relationship like this, either you did something wrong with the data, or you've discovered like an incredibly powerful economic fact, but you like never get fits to the data like this, right? Another example is cities. So here we put the log of the population of the city and the log of the rank of the city. Again, we should get a perfect -1, which is this line. Now, it's not quite so perfect, but man, is that close, right? That you would get that close of a relationship in the world. Words in English language are true as well. So this extreme heterogeneity, this extreme spaced outness of talent at the top of the distribution has several implications. One is that rents are going to be very important even in the long run, because this is going to lead to the superstar effect, because if there's these big spaced out talent distributions, there's going to be a lot of value to trying to get the best people to reach everyone. Free entry, in many ways, we could think, is actually more of an anomaly that occurs in some areas and has to be corrected by intellectual property to make sure that people still earn rents rather than being the norm. And as David was pointing out, if the top people are so much better than the next people, the big firms are so much bigger than the next firms, it's going to be pretty hard to avoid there being monopolies in an industry, or at least very concentrated industries. And that is going to lead to market power, which is going to be much of the focus of the rest of the course. So this tells us why we should think market power is going to be such a big issue, because there are these big differences. If people were more homogeneous, you wouldn't think market power would be such a big issue, right? Fourth, the income distribution is going to be highly unequal if we have these big differences in talent, and that's going to make there be calls for redistribution of wealth. And it also is going to mean that if we charge high taxes only on the very, very rich, we're going to be able to earn quite a lot of revenue off of that, because they're going to have so much money relative to everyone else, right? And so those are the types of issues we're going to be talking about throughout the rest of the course. So I think today what we studied sort of sets the stage for what we're going to be doing in the rest of the classes. And I let you off a little early again.